Page 60 asks what this number chart would look like if all the prima donna or prime numbers were gone. Well, if all the numbers divided by 2 were gone, it would look like this. If all the divisible by 3 were gone, it would look like this. Then we skip 4 since it can be divided by 2 and tap all numbers left that can be divided by 5. Then we skip 6 because it's not a prime number and straight to 7, which looks like this. Only prime numbers are left on this chart. Page 24 asks what 3 numbers can be added to make 27. The answer is 7 plus 17 plus 3. Page 103 asks what happens if we add all the cubes within the lines together. If we do that, we will get the number 25. Page 145 asks what pattern would the triangle make if all numbers divisible by 4 on the triangle get lit up. Well, this is what it looks like. Page 208 to 9 asks what number would we get if we made the figure on page 200 and inserted it into the equation d plus s subtract l. D for dots, S for sides, and L for lines. Well, we would get the number 2. You know what 1 plus 2 is, right? It's 3. But what if we didn't know what we were adding to 1? Well, we know we are adding something to 1, so we can't leave it empty. So how about we put a question mark in place? The question mark can stand for anything, unless stated otherwise. And we know the answer is 3. Now we have 1 plus question mark equals 3. Only in math, people like to put letters like X and Y instead of question marks. So let's replace our question mark with an X. Now we have 1 plus X equals 3. The X is called a variable, and just like the question mark, it can stand for anything. Now we can start solving it. We do that by getting X all by itself on one side of the equation. Let's start by subtracting 1 on the left side. Now we have X equals 3. We need to keep the equation balanced, so we subtract 1 on the right side. If you're confused on why we do that, then just for a couple seconds forget about the equation. Imagine we have 2 pencils. Then we get 2 more. In total we have 4 pencils. If we write that like a math equation, it would look like this. Now we take away 2 pencils, so we subtract 2 from our equation. But something went wrong. We know that 2 does not equal 4. What we do here is subtract 2 on the right side as well. Much better. Do you see now? If you want to do anything on one side, you must do it on the other side as well. This is called the reverse order of operations. If you recall, the order of operation has an acronym which is GEMDAS. G for grouping symbols, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. The reverse order of operation is just that, but in reverse. Now back to our equation, 1 plus x equals 3. We subtract 1 on both sides and get x equals 2. Then we plug it into our original equation, meaning we replace all the x's with 2. Now we have 1 plus 2 equals 3. And of course, this is a true statement.